Okay, so we're going to talk about even and odd functions today. You actually already have the skills to do this because it's just another way for us to describe even functions are just functions that have y-axis symmetry. So, remember testing for y-axis symmetry? How did we do it? There you go. You're just going to pop in a negative x in place of x. Simplify your function, and then see if it matches the original. If it does, then we said yes, it had y-axis symmetry. Well, another way to describe that function is to call it an even function. Okay, so we're going to try that. Then we also have odd functions. So that's when a function is symmetric about the origin. So remember testing for symmetry about the origin? We did that by plugging in a negative x and a negative y, simplifying your function and seeing if it matches the original. If it does, then we say it's an odd function. Okay, so let's try, if you look at the worksheet, let's just try number 1, right? So remember that f of x is the same thing as y. So instead of writing f of x, I'm just going to write y equals x squared minus 4. Okay, and I am going to save myself a lot of time because I'm not going to do a whole test for even and then a whole test for odd. What I can do is start by doing the test for even, and then I can just pick up from there and test for odd. So it saves myself a little bit of time. So the test for even, you're going to replace x with negative x. So I should just jot down that's what we're doing. Even test. So if I simplify this function, y equals x squared minus 4. Oh yeah, okay, cool. So here was my original. So it does match the original exactly. So this function is even. Hooray! If I wanted to test for odd, I can pick up from here. Here, I've already plugged in negative x, right? So all I have to do the odd test is plug in right here a negative y. So could negative y be equal to negative x squared minus 4? No, that's never going to work out, right? Even if I got the y totally by itself, I'd have negative x squared plus 4. So no, this one is now odd. Let's try the second one together. So again, I'm going to start off by rewriting it as y equals x to the third minus x. Okay, so there's my original. And now I'm going to test for even. How do I do that again? Yes, plug in negative for x. So I'm going to replace my x's with negative x's. So I'll do negative x to the third minus negative x. Do you see that? So I've taken my x's from the original and replaced them with negative x's. Let's go ahead and simplify this function and see if I can get it to match the original. So let's talk about this right here. What's this chunk right here going to simplify to be? Negative x cubed, right? Because if I take a negative number and I cube it, it still is negative, isn't it? Yeah, so I'm going to get negative x cubed plus x. Well, does that match my original? No, it does not, so this is not even. So now, when I go to test for odd, I don't have to start from scratch. I have negative x plugged in on the right-hand side. So what I can do is kind of just pick up from here and just make that a negative y, and then see if I can get them to match. You get what I'm saying? You don't have to redo the right-hand side. I already did it. I already plugged in negative x over there. Let's just plug in negative y and see if I can get them to match. So if I do negative y equals negative x cubed plus x, and now I try and simplify this, so I could divide everybody by negative 1. Huh, well, what do you know? That does match my original. So yes, this thing is odd. Does that make sense? So if you start by doing the test for even, you can save yourself. You don't have to start from scratch to do odd. Just pick up and go from there. It is possible that neither one works. You could have a function that's not even, that's not odd. Could you have a function that's both even and odd? Think about what that has to look like too. So you have to be able to, whatever the function looks like, if you draw it as a graph, you'd have to be able to fold it over the y-axis and they match up. And it would also have to rotate and match up about the origin. I'm not going to give you the answer just yet. I just want you to think about it. Even try and sketch it. Like if I started with, okay, so like a function, I don't know, maybe something like whatever. So that's even, right? Because it folds over the y-axis. But is that odd also? No, because I would have to have odd, I would have to take this and rotate it about the origin, so I'd have to have it over here. And I don't. So, no, all right. Maybe something cubed. We could try. So that has, that's odd, right? Because that's reflected over the origin. If I took this and rotated it around, but is it even? If I fold that over the y-axis, do they match up? Just think about it. Think if there is such a thing that exists that lets you have both. Okay, so that's pretty much for even and odd. You want to do one more together or try them on your own? Should we do a hard one together? Okay. You pick. What looks hard? 8? Okay. We'll try it. 8's a good one. So 8, you've got y equals 7x to the 2/3 power. All right. So that's my original. Let's try to test for even. So even, I'm going to replace x with negative x. Now, let's see if we can make this thing match the original. Well, would you agree with me here? Can I do this? Yeah, I haven't done anything wrong yet, right? Isn't negative x the same thing as negative 1 times x? Okay, and if I have more than one thing in a set of parentheses, and it's all one term, and I'm raising it to a power, can't I do this? Is that allowed? Yeah. That's your power rule, raising it. Oh, no, it's not. It's your product rule, right? If you have multiple things in the parentheses and I'm raising everything in there to the power, everybody gets raised to that power. So let's evaluate this right here. What is negative 1 to the 2/3 power? What does 2/3 power even mean to do with any number? Cube root, and then you square it. The denominator tells you what root to take, and then the numerator tells you what exponent to raise it to. So what is the cube root of negative 1? Negative 1. And then what is negative 1 squared? 1. So 7 times 1 is just 7x to the 2/3. What? That's so crazy. But yes, it does match my original. So this thing is even. And then I can test for odd right here by just replacing this with a negative y. Is that ever going to match? No, how could it? So it is not even, not odd. But we do have an even function here. Cool. Okay, so let me stop this video here.